Hello, do you know what is localization? Okay, let's talk a bit about localization.
তুমি কি স্ক্রিনটা শেয়ার করছো?
Oh, I forgot to share it. Michael Artin. Okay, so let's start with a question. What is a rational number? Anyone? Anyone, please. What is a rational number?
পি বাই কিউ ভাবে লেখা যাবে, যেখানে কিউ নট ইকুয়াল টু 0 এন্ড পি কিউ বিলংস টু
This, right?
হ্যাঁ,
And anything else?
আর নন রেশনাল নাম্বার মানে
Okay.
এরকম বলা যায়।
No. I just want to ask rational. So, according to your definitions, both these are rationals, right?
হ্যাঁ,
Mm, then how are you saying are they same or not? Because then all of these are there.
হ্যাঁ,
But then the set of rationals is not well defined, na? Because then you are writing the same element over and over again.
রিলেটিভলি প্রাইম হবে।
So Shubrita is saying that, sir, take this also. But in that case, the problem is 1 by 2 belongs to Q, but 2 by 4, 3 by 6, they don't belong to Q. So what should we do?
না আমার ডেফিনেশন হ্যাঁ।
So what should we do? So first, let's take Z. Okay. Okay.
না আলটিমেটলি 3/6 2/4 এগুলো তো আলটিমেটলি 1/2ই, তো ওগুলো তো একটা এলিমেন্ট।
No, you don't understand. I mean, are they in Q or not? If they are in Q, then you are writing the same element over and over again. And if they are not in Q, then 2 by 4, 3 by 6, they are not rational, but 1 by 2 is rational.
ওকে,
Let's take Z. Okay. Define and define a relation on Z by A comma B is related to C comma D if okay, we define Z cross Z modulo the equivalence class to be Q. Okay, check that one, check that this is an equivalence relation. Okay, under this we partition Z cross Z to obtain. So basically we have given an equivalence relation on Z cross Z, and this is what? This is like this. I mean, I should write this class of this, okay, or class of this, okay, where Devotion, are you understanding this? Represents
Allah.
equivalence class containing A, comma B. Okay. We denote the class of this by A by B. Understand? So this is how we get Q. Understood? Understood? Now let R be any ring with unity. You can take commutative as well. Okay. S subset of R is said to be multiplicatively closed if uh, 1 belongs to S, A belongs to S, AB belongs to S implies AB belongs to S. Okay. Understood? We define S inverse R as the following. R cross S modulo something, okay, where this is defined as follows. 1, A comma S is related to A prime comma S prime, that is, we write A by S is equal to A prime by S prime if there exists F belongs to S such that, see, what did we show there, that this is supposed to be 0, na? For Z it was like, this condition, na? This has to be 0, right? But here we get this. Check that is an equivalence relation. Okay. Check that this is an equivalence relation. Can you check that this is an equivalence relation? Okay, so let's write a statement with you. suppose A comma, one thing is obvious na, I mean if this is obvious na, this implies this na, this is obvious. This is obvious na, because this means, I mean you can multiply it minus and get that this A prime s minus A s prime equals to 0 na. So this is obvious, right? And also you have one into As minus As is 0, right? Also, thus this implies E by S, I mean I want to say this actually, A comma S is related to S, right? One is in S na. And if A comma S to A prime comma S prime and A prime comma S prime is related to A double prime comma S double prime, then there exists if F prime such that, what did we have there, if S prime minus is 0 and right. So what does it mean? It means if A S prime is F S A prime, right? And this means if prime A is double prime is equal to F prime A double prime S prime, right? E prime is here, no? Multiply this by Fs, okay? Multiply this by Fs. F prime F S A prime is double prime is equals to okay. Okay. What do you get? F is A prime, right? F is A prime. What is that? F prime put we have multiplied by Fs. So Fs A prime put Fs A put Fas prime. Right? So see, what do we have to show? We have to show A comma S is related to A double prime comma S double prime, right? That is, there exists G belongs to S such that G into A S double prime is equal to G into A double prime S, right? Oh, I mean, I forgot to write this. I mean, A is in R and S is in capital S. Okay. I mean, the left elements in the left component, I mean, the right component is in S, right? So, is it done? Is it done? I think it is. Uh, if we take f prime, f s prime common, we have a s double prime, and if we take the same thing common, f prime s f, I mean the same thing, f s, we have a prime, oh sorry, s common, right? So this is our g. Okay, so this is our g. This implies g times a s double prime minus a prime s is 0. Okay, okay. Thus S inverse R is defined by R cross S by tilde. We define a ring structure on S inverse R. Denote 1 of S inverse R by 1 by 1. Okay. 2. A by S plus A by A prime by S prime. This is defined to be, I am defining it, A S prime plus S A prime by S S prime. And AS into AS prime, I am defining it to be AA prime by SS prime. So S inverse R is a commutative ring with unity being this. Okay, 1 by 1. Okay, so S inverse R is a ring. See, I will give you guys 5 minutes to look at what I have done, because I think this is serious content. So localization, you are learning it for the first time, take your time. Okay, don't worry, I'm not ending the class, I'm just saving this for the time being so that it doesn't go away. Okay, you have 3-4 minutes, check this thing carefully. Okay, 3-4 minutes you have. Okay, so this is something called localization. Okay, this is something called, this is something called localization. So Q, how it was defined? S inverse Z, where S is right. So I actually made a mistake here.
মানে ওই ইকুইভ্যালেন্স রিলেশনটার পার্টিশন গুলো
Exactly. This is should be Z star, huh? This is Z star. Z star is. Now you observe that this is clear of any ambiguities. Okay. So according to our definition, Q becomes S inverse Z, no? We have, what are we doing basically? We are inverting the element of S, no? Right? Basically. So in S inverse R, we invert the elements of S, right? That's what you do, no? Then another thing, remark or maybe observation. There is a map, maybe call it theta, from R to S inverse R, where R, an element of S, this goes to R by 1. Okay. Do you guys know the definition of a ring homomorphism? Bhushan, are you aware of the definition of a ring homomorphism? Hello.
না দাদা।
Group homomorphism? Group homomorphism, you know the definition of a group homomorphism, na? Bhushan?
মনে পড়ছে না, তুমি বলো তো।
Let R and R prime be two rings with unity. Phi R to R prime is called a ring homomorphism if
So phi of R1 R2 equals to phi of R1 into phi of R2 or phi of R1 plus R2 equals to phi of R1 plus phi of R2.
the first, the unit should go to unit, no? Phi 1R equals to
1 R dash.
1R dashed to phi R1 plus R2 equals to phi R1 plus phi R2. Bhushan, that's the definition of a group homomorphism, okay? So a ring homomorphism should be a group homomorphism primarily. Okay. This theta is a ring homomorphism. Okay, so no, I was not actually sure of how much ring theory you guys know. Okay, so I will have to. Devotion, how much group theory do you know? I mean, if I say which of the topics are you comfortable at? I mean, in group theory, symmetric groups, homomorphism, normal subgroups. Are you comfortable in this? Deoshan, I'm asking you explicitly because you are the junior most here. So, are you comfortable?
No, sir, not really.
Acha. How much group theory have you gone through? See, I'm asking it because then I might suggest you some books or something like that. Okay, this is not to judge you.
Sir, I just started recently.
Group theory you just started recently. I mean, there was no group theory a priori in your in the first year.
No, we have it in this semester.
Oh,
No, sir, this semester.
No. I confused your syllabus with the Xavier's actually. Piash actually knows a lot of group theory because it was in his first semester or second semester. I got confused between it. Okay. No. Then it is absolutely fine. No, it's absolutely fine. Then don't worry, you will learn these things. But then it will be hard for you to understand this class actually. Okay, so symmetric groups and homomorphisms, normal subgroups. Okay. Oh, so it's a ring homomorphism. Every one of you know what a ring homomorphism is and what a kernel of a ring homomorphism is. Okay, so is a ring homomorphism. Okay, now what is the kernel of this ring homomorphism? What is card theta? Card theta is all those r belongs to r such that theta of r, which is equals to r by 1, is equal to 0 by 1, right? It is 0 in S inverse r, na? So that is 0 by 1, right? So what does that mean? All those r belongs to r such that there exists S belongs to S such that S r is 0. True? True. Like we should be writing like this. So I have this implies this. So card theta is this, na? This is clear, na? That card theta is this, right? So you observe immediately that theta need not be injective. I mean, the first intuition when I had this, I thought r going to r by 1 is of course an injective map. So theta need not be injective. Okay. So theta need not be injective if there are zero divisors. I mean, if there are zero divisors in the ring R. Understood? So the first intuition I had was that this theta, I mean, it has to be invariable, it is injective, but that's not the case. However, but suppose R is an integral domain. Do you know what an integral domain is? Apart from devotion, everybody knows. That is, oh, just a minute. I am writing all these things like zero divisors, integral domain. You guys know the definitions of these things? I mean, Shubrita?
Dada.
That is, if R is an integral domain. So let S subset of R, this is multiplicatively closed. Okay. Then in S inverse R is all the sets of like A by S, S belongs to S, A belongs to R. We saw that A by S equals to A prime by S prime if there exists S belongs to S such that F into A S prime minus A prime S is 0, right? But this implies okay, let's take another assumption here while talking about S. Let's not take 0 into S. I mean, if 0 is belongs to S, then S inverse R is basically 0 by 1. Check it. Okay. Because for every element in you have a 0, na? I mean, for every element A by S belongs to every element A by S belongs to S inverse R, you can multiply it by 0. I mean, 0 into A prime is 0, na? So basically you get 0 into A prime into 1 minus S into 0 equal to 0. Okay, that is you get A by S is equal to 0 by 1. Okay, so S inverse AR becomes 0 if 0 belongs to AR. Yes, 0 does not belongs to S. This is another assumption. So this implies what? Since it is an integral domain, we have AS prime equals to A prime S, right? Right? So for integral domain we have this. Now what about that? I mean, what about now? I mean, the R2S inverse R. What about this? R2S inverse R. Then card theta is again all those R belongs to R such that there exists S belongs to S such that SR is 0, right? But see, integral domain has not 0 divisor, right? it has no zero divisor, na? So the only possibility is r equals to 0. Understood? So theta is injective if r is an integral domain. Clear? Okay, let's see another thing. Another thing, suppose r is there and f belongs to r not equal to 0. Define s by this 1 f square and so on. Okay, just the powers of f. Then S inverse R is denoted by RF. Okay. I'm trying to think about whether something is okay. Why I am saying all this? Suppose R is a ring with unity and F belongs to R. Can we invert F in some ring? So the question is, F is an element in R, okay, and suppose F is not invertible, I mean F is non-unit, okay. So can we invert F in some ring, some other ring? So the solution is, of course, what we do, we just take S to be 1 f square and all that, and what do we know? We know that 1 by f belongs to this ring S inverse R, Rf, okay. So we can invert f there, right? Right, na? So we can invert f there. Now right, we can also write Rf to be this R 1 by f. Understand what is this? Do you understand what is this? Do you know the notation, I mean the meaning of this notation? Rx. This denotes polynomials in X with coefficients in R, right? That is a0 plus a1x up to a2, I mean an x to the power n, where ai belongs to R and n belongs to natural number. I mean n varies. Okay, that is, I mean, the set of all polynomials. I think you have noted these notations, right? Qx, the set of polynomials in Q, I mean over Q. Rx, set of real polynomials. Zx, you have seen these notations, I think. So by that very same notation, R1 by f is defined to be this way: summation ai. When we write ai, I mean we are writing like this: ai belongs to R, right? Okay, this is, you have to understand this ai, I mean by as ai by 1. Okay, you write this ai by 1. Now this multiplication you can make the meaning of it. Okay, in, I mean in RF na. So are you convinced that this is this true? I mean, are you convinced about this equality? Tell me, are you convinced about this equality? Are you convinced about this equality? So all of you are very quiet. Okay, so okay, we will talk about things, don't worry. But I think I will have to teach at least some part of ring theory because I'm not. Okay, do you know ideas? Do you know ideas? Students from BSc third year, M.Sc, do you know ideals in a ring? Hello?
হ্যাঁ দাদা জানি।
হুম। Hmm. So what is an ideal? I subset of R. So R, again we take R ring with unity. Okay. Maybe commutative. Okay. So what is so if R S belongs to I, we have R plus S, R plus minus S belongs to I, and if S belongs to I, R belongs to S belongs to I implies RS belongs to I for any R belongs to R, right? So we saw normal subgroups in a group, right? There are subrings in a ring. So which is a subring? So these two satisfied by subrings, huh? The first two properties. So any ideal is a subring. There are subrings in a ring. Okay. Question: why do we need ideals? Anyone? Why do we need the notion of an ideal? Any one of you? Yasha? Why do we even need the ideals? Recall that if G is a group, then G mod H is, and H is a subgroup of G, then G mod H is not always a group, right? If H is normal in G, then G mod H is a group, right? Right?
হ্যাঁ
So let I subset of R be just a subring. Okay, we don't know whether it is ideal or not, just a subring. So you define R mod I by just the cosets, huh? Just the cosets. R plus I, where I belongs to R, R belongs to just the cosets. Can we define product on R mod I is a group, right? As I is a subring, hence a subgroup. R is abelian with respect to the group operation, right? By definition, a ring is an abelian group, right? So I is a normal subgroup of R, right? Is an abelian group, so every element in I is every subgroup of R is normal. So can we define a product on R? So we want to define R plus I into S plus I. The obvious, this should be the definition, right? But the problem is, let's take no, not R, just a minute. Let's take S belongs to I, okay, or maybe S prime belongs to I. So take R plus S belongs to R plus I from this coset, and R prime plus S prime belongs to R prime plus I, this coset. Multiply these two. This is inside this coset, right? What is it? R prime plus R prime S plus RS prime plus SS prime, right? Right. Oh, there was this criteria, sorry. R dot S and R plus minus S. So you observe that this is in I, right? But what about these two terms? What about these two terms? So this is in I and this is in I if I is an ideal, right? Right? If I is an ideal, then by the definition of I is an ideal, these things are in I, right? So by definition of an ideal, by this third criteria, these things are in I, okay? So this whole thing are in I. So now the product is defined. Understood? So R mod I is a ring and the natural group homomorphism map, group homomorphism from theta to R mod I is a ring homomorphism. Here I goes to R plus I. As, why is this the ring homomorphism? As theta of C, 1 is 1 plus I. Which is the unit in this? Now theta r plus s is r plus I plus s plus I. Because theta is a group homomorphism, na? As theta is a group homomorphism. Theta r prime, we have seen it to be r prime plus I, which is r plus I r prime plus I, that is theta r, that is theta r plus theta r prime. Okay, so this becomes a ring homomorphism. Understood? That's why we need the notions of an ideal. I do think you guys need to revise the ring theory a bit. Okay, so I don't know whether I have that book available or not. It's a good book to revise. Just a minute, let me see whether I can download it or not. What the hell is this thing? What? What is this?
দাদা হাঙ্গার ফোর্ট থেকে রিভাইজ করলে হবে না?
Hobby, but Hungerford is a bit tougher. I mean,
আচ্ছা
I would suggest to read from this book and then go for exercises in that book. Can you download this book? I mean, is that doable? No ebook available, they have written, but can you print it? No, that's not the way to do it. Try new Google Books. Can you print it directly? I mean, by Control P? That was my concern. If you're going to print it. No, that's the thing. Suppose you write it something like this, 150. Let's see what's there. No, it doesn't make sense. So you have to read it directly from here. There is no other way. Control C.
দাদা এটা কি পুরো বইটা নাকি প্রিভিউ?
কেন বলতো?
পুরো বইটা বেশিরভাগ সময় থাকে না এমন গুগল বুকসে।
Oh
আছে কি?
dear, oh dear. No, 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 no. No, no, only the preview. You are right. Oh, okay. So let me see if I can download it or not. The commutative algebra book is very famous, but I am looking for university algebra. Okay, okay, okay. Let me see what can I do. Shubrita, what were you saying? Whether you can uh, revise from Hungerford or not? No. Let's see. Rings and homomorphisms, ideals, factorization of commutative rings. Questions: localization, rings of polynomial, formal power series, factorization of polynomial. Okay, Shubrita, let's go from Hungerford. Okay, and I will tell you whatever extra is needed because there is no other way. Is Hungerford uploaded?
পাঠিয়ে দিয়েছো তুমি গ্রুপে? Hmm. Does? Okay, then let's go slow because not many are presenting and there are exams also going on. So let's go a bit slow. The basic definition of rings, I think you know. Okay, see. So I will teach you the next section in the next class. I will request you to go through the first section of rings. Okay. Just read the basics. I mean the first section of rings. Okay, nothing much is needed. Just read the first section. Rings and homomorphism, that's it. Okay, so let's conclude today because I don't know when this computer is going to be shut down again.